Yes, good evening all.
Good evening, sir.
Good evening children, how are you? I'll upload your results today beta.
Okay, sir.
Okay, in the last class what we were discussing?
Triangles. Sir, we discussed about the sum of two sides only.
Sorry?
We discussed about sum of two sides, sir. Sum of and distance of two sides of a triangle.
Yes,
And perpendicular line segment in the shortest.
yes, great. So we'll continue with that. So this is the thing we were discussing with. So see, basically everyone should note this. See here, this symbol denotes what beta? Similar to. If triangle AB is similar to triangle PQR, we denote like this. Similar symbol, that is a similar. Okay. What is that? That is similar symbol. So let us similar symbol. This is similar symbol. Okay. So the relation is similar to satisfies the following properties. What are they? Look at this here. If it is reflexive, sir, my test glitched and clicked and submitted for me. I didn't even open. Okay. So okay, no problem, Vishnu. So it is reflexive as every figure is similar to itself. It is reflexive as it is reflexive as every figure is similar to itself. Okay. It is symmetric as A is similar to B and also B is similar to, what is that? A is symmetric as, it is symmetric as if A is similar to B as B is similar to A. Okay. Reflexive is nothing but what? Every figure is similar to itself. Reflection. Understand my point? And if transitive is nothing but transitive as, one second, let me erase this. Transitive, it is transitive as A is similar to B is similar to C, and A is similar to C. Very, very important. And the relation similarity equivalence relation is nothing but, guys, I'll tell you, this is very important for you. In your class 12th also, you'll be learning this beta. There are types of relations. First type we will be learning is identity relation. Identity relation. After that, you will be learning about reflexive relation. Reflexive relation. And you'll be talking about symmetric relation. Symmetric relation. Next, we'll be talking about transitive relation. Transitive relation. If a relation is reflexive, symmetric, and transitive, that would be called as equivalence relation. That would be called as equivalence relation. That is what he is talking about here. So similar is nothing but what? So when can you say two triangles are similar to each other? If it follows reflexive. It is reflexive as every figure is similar to itself. It is reflexive as every figure is similar to itself. Reflex is nothing but it should reflect. Symmetric is nothing but if A is similar to beta, A is similar to B, then B must be similar to A. Then only it is symmetric. Okay, getting my point. If in reflexive, what is that? It should be same as that figure itself. Symmetric is nothing but if A is similar to B, then B must be similar to A. That is what symmetric.
They are
Symmetric.
like mirror image.
Yes. Transitive is nothing but if A is related to B. I mean, if A is similar to B and B is similar to C, then A is must be similar to C beta. Then A must be similar to what? C. This is the condition we have learned here. Any doubts?
No, sir.
If A is similar to B and B is similar to C, then A must be similar to C. If not, then I cannot say it is a transitive relation. Understand my point? If a relation is symmetric, reflexive, sorry, if a relation is reflexive, symmetric, and transitive, that would be called as an equivalence relation. Any doubts?
Sir, I didn't understand 3 points. Can you explain once again?
What you didn't understand?
Sir, those 3 points. So like, can you show it through diagram?
It is not like showing the diagram. It's a very simple. I'll tell you.
So it's only statements. Okay.
Only
So,
statements. I'll tell you. Again, you'll be learning in class 12. Okay. Look at this. First, let me talk about reflexive.
so your voice is low.
Let me talk about reflexive. Reflexive is nothing but there is a figure. If this figure is similar to that itself, means that's a reflexive beta. Okay, let's say this is a figure. That has to be similar to that figure only, a figure only. Understand my point? That is reflexive.
Okay, sir.
Symmetric relation is nothing but if a figure is this a figure, A is similar to B. Okay, then this B also must be similar to A beta. Then only we call that as a symmetric. Any doubts?
No, sir.
Sir.
Next, transitive. If A, this is B, this is C. Okay, this is A, this is B. If A is similar to B and B is similar to C, then A must be
Similar to C, sir.
C. Then only we call that as a
Similar to C,
transitive.
sir.
Understand my point?
Yes, sir.
Lalit ji,
Yes, sir.
any doubts?
No, sir.
You'll be learning again in class 12. Don't worry. It's a very good concept, very important and very simple as well. Next, similar triangles. We'll talk about a concept called similar triangles.
Sir, can we discuss the question paper at last?
No?
Can we discuss the question paper at last?
I didn't get you.
Can we discuss the question paper at last, sir?
Question paper.
Yeah, sir.
Didn't you
Because I have a
understand that?
doubt. I didn't understand the 12, 13, and 15 questions.
Sorry. Okay, we will discuss. Last 15 minutes, we'll discuss the question paper. Okay.
Okay, sir.
Is it clear?
Okay,
Last
sir.
15 minutes, we'll discuss the question paper, please. Okay. It's a very simple question. 15 minutes is more than enough. Someone of you remind me. Okay. Similar triangle is nothing but what? If two triangles are said to be similar, if and only if their corresponding angles are equal, beta, and corresponding sides are proportional. Okay.
Yes,
What is
sir.
that? Corresponding
Uh,
angles are equal. If A angle should be equal to a D angle, beta. Okay. B angle must be equal to C angle, beta. Sorry, E angle. This angle C must be equal to angle F, beta. Then only I could say the
Yes, sir.
corresponding.
These are we learned this last class.
Yeah.
Yes, sir. For all this.
And their sides must be proportional, beta. Sides must be proportional is nothing but here AB by DE. Okay. Next BC by EF. And this AC by DE. DF. Okay. Must be proportional. Sides must be.
What if
Sir,
they are,
congruent, sir, like it is.
it's
Yes,
not
that is what.
congruent.
That is what. Congruent is nothing but what?
Yes, sir.
Same thing. It's like the same only. Just we learned
You
yesterday, right?
told the example like putting the triangle on another thing.
I'll show it to you. Wait. We have learned one beautiful result. I'll show it to you.
So, but they're not congruent, right?
Look at it here. Two congruent figures are always similar. But similar figures need not to be congruent. Two
Yes.
similar, two congruent will be always similar, beta. Congruent will be always similar. But similar need not to be congruent. Understand my point?
Yes, sir.
Yesterday we have learned. That's what
Yes.
we are saying. That's what I'm saying.
Sir, I have a doubt, sir. Like, what if like these sides have the same proportion, but this side is like bigger than that side?
I didn't get you. Tell me.
So now, like AB is smaller than DE. Next, AC will be bigger than DF. So will it still be in the same proportion? No, right?
No, 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 no. Proportion is nothing but what better? Because this, let's say this is 4. This is 8. Okay. AB is 4, right? Okay. Now let's say this is 3. This is 6. Let's say this is 6.
This is 12. So, sir, like BC can't be 6 and EF can't be 3. Not
No,
like
I'm telling you, I mean, like, they're proper, the
Sir,
ratios.
we are talking about angles, sir.
No, no, angles should be same. I'm talking about the, sides. Proportional. If AB is 1 beta, D must be 2. BC is 1 means EF must be 2. AC is 1 means
okay.
DF must be 2. Their ratios should be same. 1:2, 1:2, 1:2, like that.
Okay, sir, understood.
That is what I'm trying to say here. Understand, Lalit?
Yes, sir.
So similar triangle is very simple actually. Next, what is the criteria for similarity of triangles? What is the criteria for similarity of triangles? Criteria for similarity of triangles. If in two triangles, if either corresponding angles are equal or a ratio of corresponding sides are proportional, then two triangles are similar to each other. What is
So
that?
A M1.
1 second. If two triangles are corresponding, if two triangles are similar, when can you say if the corresponding angles are equal or ratio of corresponding sides are proportional to each other, then I can say that they are similar triangles.
Both of them should be like true or anyone.
Or he is saying ratio. Look at this here. What he has given here. Here, similar triangle is nothing but when can you say similar triangles? Both if corresponding angles and corresponding sides are, uh, corresponding angles must be equal and corresponding sides must be proportional to each other. Then they are similar triangles. What is the criteria for similarity of triangles? Similarity of triangles. So two triangles, if either the corresponding angles are equal or corresponding sides of the equal, then we can say that there is or mentioned. Then two triangles are similar to each other. Now we'll see an example. Don't worry, you will understand it. Here triangle ABC and triangle DEF. Here A must be equal to D beta. Okay, angle B must be equal to E beta. Angle C must be equal to F. Okay, then triangle ABC is similar to triangle DAF. Okay, what is that? Angles are equal. Then this is what called as triple A angle criterion. Isn't it? Huh. If AB by DE beta, there is corresponding sides are proportional to each other, then this property called as triple A's criterion. Any doubts? This is
Sir,
what
can
called
you
as.
explain once again,
No.
please? That triple A.
Arey Babu, it's very simple, Babu. Already we have discussed. This is not the first time we are discussing this. Okay. All the angles, beta, corresponding angles A and D, B and A, C and F.
Yeah, sir.
Then this, a triangle ABC is similar to triangle DEF. That is what I can say. When if their corresponding angles are equal to each other, this property called as triple A. Okay. If their corresponding sides are like this.
Okay, sir.
Sir, in that example, sir, like AB is equal to AC.
No, no, it is not like that. It
No,
is
the ratio is equal.
ratio I'm talking about. AB by DE. Look at it, this AB and this AB is the red. This ratio has to be equal to what beta? This ratio. This 1 second, guys.
Yes, sir, the D one.
1 second.
And AC should be equal to DF.
This AB is the red. This by this ratio and this by this ratio. This by this ratio has to be proportional. All the ratios should be equal. But I mean to say that this ratio, this ratio, this ratio, everything should be equal.
Then it will be triple S.
That will be what? Triple S criterion.
Triple
All
S.
sides are proportional to each other, right?
Yes, sir. We talked.
Yes, very simple actually. Next.
Sir, privilege means all sides.
1 second. I think it is very difficult for me to. Yeah. AB, this should be followed very strictly. Okay, then I could say that triangle ABC is similar to triangle DAF, and this property is called as triple S criterion. Very simple, right?
Yeah, sir.
Next, now look at this here. If AB by DA and AC by DF, if AB by DE, okay, and this AC by DF, okay, and angle A and D. You try to understand carefully here. This side, this side, this side, this side, and this angle, this angles. Okay, if they are equal, then this is following what? Side, angle, side. What is that? Side, angle, side. Side, angle, side. Criterion. Understand my point?
Yes, sir.
Side, angle, side criteria is what? Side, angle, side criteria is what?
Sir,
AB
the
by
side
both sides and in between one angle
AB
if they are
by
equal to each
DE is
other.
equals to AC.
Yes, sir. This is not like congruence. Yes, I just got confused with the
Exactly. Right. Now, results on areas of similar triangles. Results on areas of similar triangles. Look at this, the ratio of the areas of two similar triangles is equal to the ratios of squares of any two corresponding sides of the triangles. Very, very important. Areas of similar triangles you're talking about, the ratio of the areas,
corresponding sides.
the ratios of areas of two similar triangles is equal to the ratio of the squares of any two corresponding sides of the triangle. What is the meaning of this? What is the meaning of this? Let's try to understand this. Okay, so see here, very simple. Here triangle ABC, this triangle is similar to this triangle beta. This triangle is similar to this triangle. Okay, the area of the triangle ABC divided by the area of the triangle DEF is equal to AB square by DE square. Okay, ratio of in the area of the two similar triangles is equal to ratio of the squares of any two corresponding sides. Ratio of the squares of, look at it here, this side, this square of AB square divided by square of DE square is equal to square of BC square divided by square of EF square. Okay, square
We
of
get the three sides.
square of D, that will be equal to AB square by DE square is equal to BC square by EF square. And you can say that A or AC square by DF square or FD square. That is what's equal. Basically, what
Sir,
we learned,
can
I'll
take
tell you. Any
ratio.
triangle, any. Look at this here. Any two he has given, any two. Look at this. Any two corresponding sides of the triangle.
Sir, if it is only similar, then only two.
We are talking about only similars, right? That is why.
Yes.
Okay, what is the result we have talked? We have what we have
If it belongs
spoken
to
about?
only similar.
Wait, ratio of area of this triangle to the area of this triangle. Okay.
Sir, any of the three sides, right?
Any of the two sides, not three sides. There are only three sides, man. Then how come you say only any three? Any two sides, not three. This can be equal to this Rababu. This can be equal to this Rababu. This can be equal to this Rababu. You understand,
Yeah,
Rababu? Here AB by AB square by DE square. This can be that. Or area of triangle ABC. Let me write the variations here. Area of triangle. 1 second. Let me simply write area of triangle ACPC upon area of triangle DAF is equal to, you can write AB square by DA square is equal to BC square by EF square, or area of triangle ABC whole divided by area of triangle DEF is equal to, you can say any two sides I said, right? AB square by DE square is equal to, you can say simply CA square by FD square now, or else you can say area of, area of triangle ABC.
Suppose they ask ratio of the area of DEF to ABC, then it will be opposite, right?
Exactly. You can find out if they given two ratio, third ratio, you can find it out very easily by using this. Given, understand my point? So you can say AB square by DE square is equal to, or else you can say simply, or this can be
AB
square by EF square is equal to,
CA square by FB square.
okay, understand my point?
Yes,
Let
sir.
me note it out. This is the one combination, okay, and this is the one combination. Sorry, this is the one combination. This is the one combination, and the another combination is this one. Another combination is this one. Look at this. Understand my point? So just three different combinations you can write. So area of any two triangles is equal to ratio of squares of any two corresponding sides of the triangles. And that is the first point, okay? The
So
second,
suppose they say DEF to ABC will be opposite.
sorry?
So suppose they say ratio of DEF triangle area to ABC, then it will be D
Opposite,
square
exactly.
by.
Yes, yes, yes. Okay. Any doubts? Any doubts?
Sir.
Next, the ratio of the areas of two triangles is equal to ratio of the squares of their corresponding altitudes. Same point, but here the ratio of the areas of two triangles, similar triangles, you got ratio of the squares of any other two corresponding angles. Square of any two corresponding sides of the triangles. And here also same thing, altitudes. So any ratio of the squares, of the corresponding altitudes. Now look at, let us say this is AX altitude, this is DY altitude. So area of the triangle ABC is equal to AX square divided by, area of the triangle ABC divided by area of the triangle DF is equal to AX square divided by DY square. Okay. Getting my point? Any doubts?
It's any altitude, right?
Any altitude means what altitude? You can see that from A to BC I'm drawing an altitude. From C to AC I'm drawing an altitude. Exactly. You can say
any
now
two
any two.
corresponding.
Any not two corresponding. Anyone. Anyone is fine. He's not mentioning any two here. Anyone. Anyone. You understand? Lalit, need not to be two altitudes. Here AX and DY are altitudes of corresponding triangles here. You understand
Yes,
my point?
one altitude, yes.
One altitude. So ratio of the areas of two similar triangles equal to Ratio of the areas of two similar triangles is equal ratio of the sum of their corresponding altitudes. Next, that is the second point. Third point, what third point says here? Third point says that, look at this. Ratio of the areas of the two triangles is equal to ratio of the squares of, one second guys, ratio of the two similar, ratio of the areas of two similar triangles equal to ratio of the squares of their square. One second here, this like is troubling a lot. This highlighter troubling a lot.
Sir,
Yes.
can you show the B1 second condition? I will take the screenshot.
Wait, I'll share the notes, don't worry. The ratio of the areas, the ratio of the areas of two similar triangles equal to ratio of the ratio of the squares, the squares on their corresponding medians, squares on their corresponding medians. Okay, squares on their corresponding medians. One second, guys, it is going on. Okay, squares under corresponding medians. So for suppose in the above figure he has given, look at this here. Here triangle ABC is similar to, let's say, triangle PQR, and here AD and PS are medians. Beta, what is that? Medians. Medians. Median. What median does here? Median does that, median divides the line segment
It
in
is
equal
the
parts, BD
yes,
and DC. Okay, QS SR. So QS
perpendicular.
and SR. Okay. So the square of that medians is also, look at each other. AD square divided by PS square. They are corresponding medians. Understand my point? Any doubts, people?
No,
Children, any
sir.
doubts? Very important. So what we have learned so far? Ratio of, ratio of areas of two similar triangles is equal to what? Ratio of squares of any two corresponding sides. Ratio of,
One is also fine. Like area of
yes,
ABC
you
by
can say, look at this here, look at this here. Any two sides you can say, or else you can say, look at this here, one is also fine. You can say this is equal to this, or this is
yes,
equal to this, or this is equal to, or anyway equal only, right?
all three also yes, sir.
You can say that. Why? Because anyway they are equal symbol. Okay.
Yeah.
Next, the ratio of the areas of two similar triangles equal to the ratio of the squares of their corresponding angle bisector. Angle bisector. One second.
Yes, sir. It's
Okay. Similar triangles equal to ratio of the squares of corresponding angle bisector. So AB angle bisector is nothing but what? Look at this here. It divides into equal angles. Like this, then this, and this. Okay. So in triangle ABC, DEF, AP and DQ are the bisectors. AP and DQ are the bisectors of what? AP and what? DQ are angle bisectors of whom? Of angle A and
And
angle
angle D, sir.
D.
yes, sir. Any angle
Right.
bisected.
Yes.
A,
Respectively. Then area of triangle ABC is equal, divided by
So
area of triangle
same
DF
it
is equal to AP square by DQ square.
sir,
Same
it
as,
is connected
same
to
as like
same.
an altitude, same as like as altitude, same as like as medians. That's it. But we are calling with a different names. Here angle bisector, here median, here perpendicular. Altitudes. That's it.
isosceles angle all are same, like medium and altitude and angle
No,
bisector
no, no,
all
no. How
are
come they are
same.
same, man? No, 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 no. Look at the altitude is nothing but I'm drawing a perpendicular line to opposite side, or I'm drawing a perpendicular line to the opposite side from the D. Okay, that is different. Now here, okay, altitude, that is altitude. Here, median is nothing but what? From A, I'm just drawing an equal, one second. From A, I'm drawing a line segment to D. Sorry, D. Then this BD would be equal to DC. That is the definition of the median. Okay, that is the job of the median. Now bisector is nothing but what? Bisector is nothing but what? The bisector
Sir,
of
it
the
divides into two equal parts.
that will be dividing into two equal angles like this. This angle will be equal to this angle. This angle will be equal to this angle. That is what the perpendicular
But like
bisector.
the median in the isosceles angle will make 90-degree divide into two equal parts and also angle bisector, right?
Yes,
I've learned. So it functions as all three, right? That's what I'm talking.
sorry.
So like
Yeah,
the
yeah, yeah.
median.
Yeah. You squaring you are doing, right? AP square, DQ square. Square.
So can we
Tell me.
No, sir, I'm saying that the median functions as all three, divides the, in isosceles triangle, it divides the base into equal parts. It also bisects the angle, and yes, it divides
Yes,
functions as all three, and also forms 90 degree.
exactly.
Yes. So, like, but can we say like the median and altitude are equal length in isosceles? We can't say, right?
Sorry,
Sir, but we can we say like the medians and altitudes are same in length in isosceles?
median and
Altitudes are same in length in
depends,
isosceles, right?
depends on the triangle. Depends on the triangle. You don't worry, don't worry. We'll solve the questions based on that as well. It will be cleared for you. Depends.
Sir,
Okay, guys. Now, what do you call this? Next, and this Thales theorem I'll discuss tomorrow. We'll discuss the question paper now. Are you guys ready?
yes, sir.
Just a minute. Just a minute, guys. Yes. The first question already we did. The second question, how many have we done?
Yes, I've done it. It's
Done it.
yes, sir.
Yes, sir. It's B.
Sir?
Yeah.
Sir, we can tell you that if two angles, we can tell. Yes,
So next one is ASA, then isosceles, and then equal.
yeah, sir.
Yes. For two triangles, two angles, and the included side of one triangle. Included side of one triangle are equal to the
Sir, yes, sir.
equal to two angles and
Sir,
included
we
side of
can
another
tell.
triangle.
Sir,
Two
it
angles,
says
two angles and included side. What is that?
yes, yes, sir.
Yes,
Huh?
yes.
Yes, sir.
ASA.
How many have,
ASA.
how many have we did with the same?
Sir, I also did the same.
Sir. Nehal.
How many have we done with the same? Guys, I'm asking you people only how many have we done with the same? ASA is the answer. First one is 55 degrees. Very simple.
Next one's isosceles.
Two angles and included side of one triangle is equal to two angles and included side of another triangle. A triangle is two sides are equal is nothing but isosceles triangle.
Yes, sir.
Next, the angles opposite to
Sir, it's a theorem.
Equal.
So it's a theorem, it's equal only.
yeah, two angles opposite to equal sides.
Yes, sir.
Equal.
And the sides opposite to
Equal.
equal.
Look at two angles opposite to equal sides are equal actually. E and F
And,
are midpoints.
and the sides opposite to equal.
E and F are midpoints of equal sides.
So BF is equal to CF.
Yes, sir. BF is equal to C. Sir,
A
I
is the
need to.
midpoint of sides AB.
Sir, in isosceles triangle, we have learned that you need to
And F is
altitude.
the midpoint of AC. Yes.
Two altitude should
Of
be
the
equal.
triangle. Then what is that? Here EF is equal to BC or not?
Yes. We can draw the C from E.
I mean BF. You can say BF is equal to C. Can I say BF is equal to C?
Yes, sir. I need
How?
to altitude should be equal in isosceles triangle.
Look at it here. 1 second. Let me show.
Or by SAS and all. Yes.
Can I say now? Here AB and equal sides, beta. A, B and AC are equal. Okay, okay. Isosceles triangle. So A is what common side? I mean common angle for both the things. A is the common angle or not? Yes. And here
Yes.
AE, here AE and AF beta. This AE is the right. This AE and AF. Half of the equal sides. Half of the equal sides or not? Now can I say triangle A, B, F, triangle ABF, this triangle is
Sir,
similar
we
to
can
triangle
draw the
ACE, triangle ACE, this triangle, both are equal by SAS rule, side, angle, side.
Yes, sir.
So by using CPCT rule, can I say BF is equal to CE?
Sir, we can draw like that also, but we can draw from the C to E and B to F triangle.
Yes,
Like
sir.
that.
I didn't get your point.
So means you can draw the triangle and we can show that C to E and B to F like that also. So no,
No, look
but
at
we
it.
can.
What I'm trying to say here is very simple. Listen to me carefully.
SAS or that altitudes, any two altitudes are equal.
Here. Okay. So what I'm trying to say here is this triangle beta. This triangle is this red color triangle is equal to
BCF.
this blue color triangle. Both are congruent to each other. I'm saying why? Because look at it, this side of this triangle and this side of this triangle, 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 this side, both are. I mean all the corresponding sides are equal. Can I say side, angle, side, side, angle, side? Look
Yes,
at
sir.
this.
We can say.
Yes, sir.
Side, angle, side beta. Side, angle, side.
Yes, ABF and AC. Yes, sir.
Next, side, angle. 1 second. AC, AC, right? Side, angle,
Side. Yes, sir.
or else here is side, angle, side. ACAS. So BE,
Yes,
definitely BF. This BF and CF would be both are equal definitely.
yes,
Yes.
sir.
Next, ABC is an isosceles triangle in which altitudes BE and CF are drawn on the equal sides AC and AB respectively.
It's
Get my point?
yeah. It's the same thing.
Same thing it is.
ABC is an
But any two
isosceles triangle.
altitudes are equal in a triangle.
ABC is an equilateral, isosceles triangle in which altitudes BE and CF are drawn to equal sides. BE and CF are drawn to
Yes, sir.
equal sides.
Again, SAS, sir.
BE and CF. This is E, this is F.
ABE and ACF.
ABE,
And ACF.
ABE and this one
ACF.
ACF.
C and F. Yes, yes, yes.
So can I say now BE is equal to CF again? Same
Yes.
question actually, almost same question. Next, if ABC and DBC are two isosceles triangle with the same base BC, then what is that?
Yes,
Angle
ABD
is
is
equal
equal
to angle AC.
Yes,
This
sir.
is a two triangles with it. This is a triangle beta. Okay.
And like I drew them inverse, like
A,
this one first.
B, B, C. Okay.
So they asked ABD, so I took them both on the same base, but like, so like a tile, rhombus, I took them.
On the same base. Okay, here only to change is what A vertices. Okay, so AD is what now?
So yes, sir, on the same base, sir, like a rhombus, sir.
You draw like this. What is
Yes,
this?
sir, like that. ABD is equal to ACD, yes, sir.
A,
Because
B,
both are isosceles, that
here
angle and that
B,
angle be
B, C.
equal. So if
B,
you are
C.
equal to equal, they're equal, like Euclid's
Yeah,
axiom. Yes,
look
sir.
at it here. AD is the common side. I mean, AD is what common side for both the triangles. This, look at this is the one triangle now. This is another triangle. Clear? AD is the common side for both the triangles. Getting my point. AB and AC are what? AB and
Yes, sir,
AC
by
are what?
SSS, by SSS, sir.
Here this AB and AC are sides of an isosceles triangle. Can I say that?
Yes,
So
sir,
BD is equal to CD here. BD will be
BD is equal
also
to
in the CD.
CD.
Now can I
And
say?
AD is the common.
And AD is a common already. Now can I say ABD triangle is similar to triangle ACD?
By
By,
triple S.
by what? By
Triple
using
S.
the CPCT rule. Here AB is equal to AC.
ABD is equal to ACD angle is by CPCT. Yes,
And
sir.
this is the common side. Can I say yes, yes? Yeah. So by using the CPCT, I can say that it is ABD. ABD is equal to ACD. This angle will be equal to this angle. Very simple. Hope you are getting my point.
Yes, sir.
This angle will be equal to this angle. Next. AB is an equilateral triangle. Each angle would be 60 degrees.
Degree, sir.
Yes, sir.
Next, ninth question. AD is an altitude of isosceles triangle.
So then BD is equal to CD. We learn this will
Then,
bisect equally.
yeah,
Yes.
in which AB is equal to AC beta. AB is equal to AC. Then BD
Yes,
is equal to CD. Yes, it will be bisecting. Very simple. Option A.
yes, sir. Any median, anything, it will function as altitude and median. Nice.
Yeah. So here why? Because if you divide this is the one triangle, this is another triangle. Okay. Here a triangle ABD is equal to triangle ACD. Correct? And ADB is the ADB is 90 degrees and ADC is also 90 degrees. AB
So it's
AB
also
and
angle
AC is the common
bisector
side.
of.
Yeah. I mean AB and AC both are equal here. AD is what? Common side for both things. Now can I say triangle
And the angles are STS.
ABD similar to, I mean equivalent to triangle ACD?
This one
By
by
what?
S.
By not
Yeah.
RHS Babu. Right angle RHS congruency. So BD is equal to what now? CD here. By using RHS.
Sir, but there's a common side, right? So how is it?
So what? Look at it, I'll tell you. Here ADB is equal to ADC. ADB is equal to ADC 90 degrees. AB and AC both are equal.
Hypotenuse, yes.
AD is common.
Okay, sir. Common side.
Common. Now can I say this triangle? Look
Yes,
at
sir.
this blue color triangle. This blue color
RHS.
triangle equal to this. This triangle both are equal or not? Yes.
Yes, sir.
So can I say now this?
Yes, sir.
BD is equal to DC. Of course, both
Yes,
are
sir,
equal.
we don't even need to use this for
Yeah.
like
In a right, yeah, here look at it. In a right angle triangle, the longest side is hypotenuse.
hypotenuse.
The which of the following is not criterion for the congruency?
Or SSA.
Yes, we don't have. And in which triangles ABC, PQR, AB is equal to AC, C is equal to P, P is equal to Q, then the two angles are what?
Yeah, they're isosceles but not congruent, sir.
But not
Because
congruent. Look at it. This is the one triangle.
So yes, sir. In this, I had gotten confusion A and B.
yes, sir, like PQR, sir, it's not corresponding. They are equal, but they're not corresponding. Yes.
It's PQR. So here AB is equal to AC beta. Okay. This
Yes,
P
sir.
is equal to P.
Angles is equal to angle P, sir. It should be equal to angle Q if they are congruent.
Yes.
They're not corresponding angles. So yes, sir. Like if you want to make them congruent, then it should be something like QP or something.
PQR, this angle and this angle both are equal. This angle and this angle both are equal. Then two triangles
Yes,
are
there should
called
be
isosceles but are
RQP.
not congruent.
There should be RQP.
Look at, let me
Yes.
tell you. Let me tell you. If I draw like this, what are the here? P, Q, R. Here C given as P beta, but not corresponding. They are not corresponding angles. Right here, this
Yes,
they
sir.
are at different positions. Here B is
Yes,
equal to Q given. Here C is not C and P are not corresponding angles there. Okay. C
Yes,
and
sir.
R are corresponding, so they are isosceles but not congruent.
Yes, so it should be equal to RQP something, RPQ. Yes, sir.
RPQ something, then would have been not RPQ, RQP,
RQP, yes.
RQP. Then would have been correct. Yes.
Yes, sir.
Triangle PQR is equal in triangle
Sir, 5 only, sir, length. No, sir, 4.
PQR, R is equal to P beta. Okay, these two are both are equal. QR is
So
4.
then PQ and QR are equal. PQ and
The length
QR.
of
So it
PQ is what?
is 4. 4,
Length
sir.
of PQ is what?
4, sir.
R and P are both are equal. Opposite to equal sides. Opposite to equal sides.
Opposite to equal angles are equal.
This
Yes,
also
sir.
4 only. This is correct. Opposite to
Right,
equal
sir.
sides. Opposite.
Yes, sir.
Opposite.
Opposite
I
to
mean
equal.
sides opposite to equal angles. Sides opposite to equal angles are equal. So this one is 4. Then this one is also going to be 4 or not? Yes.
Yes, sir. Understood.
AB is equal to QR, BC is equal to PR, QA is equal to CQ, then
Yes,
triangle
sir. You
CBA.
have to write in the order, sir.
A,
Yes, sir.
BC, PQR. A, B, C, P, Q, R. AB is equal to QR beta. Okay, let's take like this. Or P, Q, R. Okay.
Yes, sir.
AB
It should be ABC is equal to QRP.
QR,
QRP or CB is equal to PRQ. Inverse.
RP,
Yes.
RQP. BC is equal to PR. AB is equal to QR.
BC is equal to PR and C is equal to
Then
P. Sir, correct only, sir.
AB is equal to what? QR, right? I mean, AB is equal to QR, right? BC is equal to PR. P,
So it should be equal to QRP, but then if you inverse it's like CBA, it could be PRQ.
PQ.
Yes.
Look at it here. AB is equal to what? PQ or not?
Yes, sir.
So AB is equal to QR. QR. This
Q.
is equal to it.
BC is equal to
This is
PR.
equal to PR. Yeah. And CA is equal to PQ.
Yes,
Then
it should
what
be
is it?
QRP, then but the inverse the triangle like CBA. So
Yeah.
it should be
Triangle is,
PRQ.
triangle is what? CBA. Triangle
C
CBA is equivalent to triangle
PRQ. PRQ.
PQ.
It's in the order, sir. Yes, sir.
It's in the order. PRQ. Okay. This is how we got this. Okay, guys. So next 15th question is B option. BC is equal to PQ. The which are the following is not true. AC will be equal to PR.
Sir, BC should be equal to QR, not PQ. If
PQ.
they're congruent.
Yeah.
Yes, sir.
If they are congruent, AC is PR. AC is what? AC PR here.
PR.
BC,
Yes.
BC is equal to QR. Okay, this is wrong here. Option
Yes,
B is
sir.
correct. Okay, guys, I have a meeting right now, so I would like to leave now. So I'll upload this. I'll upload your results as well. Okay, children. Thank you. Have a nice day. Goodbye.
Thank you, sir.
Bye, sir.